In this lesson, we're going to build on function compositions, but we're going to switch directions. We're going to go backwards. So we're going to decompose, meaning you're going to be given a function, and you've got to develop two functions that could have been composed to create your given function. It's often easy to understand with an example. So find two functions, f and g, such that h of x is equal to f of g of x, and neither function may be the identity function, meaning you can't just say f of x is equal to x because that takes away all the thinking. It's important to note that there's more than one right answer here, okay? So you kind of got to be a little creative. So one of the things that jumps out at me is what's probably easiest is, well, first of all, notice that we're plugging g into f of x. So what could I plug in? Well, if I think of f of x as being this outer radical, so I'm going to say that f of x is equal to just the square root of x, okay? And that would mean g of x would have to be x cubed minus 4, the whole radicand. This is one possible answer. Because what would I do? I would take this expression and put it in for the x in the top one. You could get a little more creative. You could say that, all right, so maybe f of x is equal to x minus 4. Okay, so what would you then have to plug in place of the x right here to make it equal to the h of x? Well, it would need to be x cubed, so a simple answer. This would be another possibility, and there are many more. So in this example, my instructions are very similar. Again, we're finding two functions, f of x and g of x, such that f of g of x gives us this h of x function. So there's, again, quite a few things we can do here, but one of the things I notice, if I were to factor this trinomial, this would be x minus 1 times x minus 1. Okay, or this is equivalent to x minus 1 squared. So one possibility would be that my outer function, the f of x, could just be x squared. And then my g of x would be x minus 1, because if I had to plug x minus 1 into this x squared, I'd square it and I'd get that given trinomial. And since it's always possible to have others, maybe f of x and g of x are possibly something like x minus 6 for f of x. So what would g of x have to be? Well, I would need it to have the x squared, the minus 2x, and I've got to get all the way up to plus 1, so this would need to be a plus 7, so that when I plug this in right here and then end up subtracting 6 from it, I'll have the plus 1 as a constant. Okay, so there's two possible combinations there. Let's look at a third. Okay, so probably the easiest thing is to say that f of x is my reciprocal function, 1 over x, and then g of x would have to be x plus 7, because you'd end up plugging this in right here, but there are certainly other scenarios you could run. So maybe f of x is 1 over x minus 14. So what would g of x need to be? Well, it would have to be x plus, we have to go all the way up to positive 7, x plus 21. If you end up plugging this in right here, it would simplify to be x plus 7 in the denominator. Okay, so check out h of x here. One thing I notice is you might want to rewrite the denominator as negative x plus 5, and on the top you got x plus 3. All right, so what are we going to do for f of x? So if I made the top just be x, and the bottom, if I made this negative x plus 11. If I made g of x be x plus 6, this is not going to quite do it, but if I plug that into the bottom, that would give me a negative x minus 6, and then plus 11 would give me the plus 5 in the denominator. But now I'm going to definitely need to adjust the numerator, because if I put x plus 6 in the top, I need that to be just plus 3, So if I take away 3 here from my f of x, let's just verify that that does work. So if I do f of g of x, and I plug in x plus 6 into the top, and then I have the minus 3, and in the bottom I have x plus 6, the opposite of x plus 6, plus 11. This would be negative x minus 6 plus 11 then. So this is going to clean up to x plus 3 on the top and negative x plus 5 on the bottom. So it works. Okay, so these are just definitely things that you need to practice, a little bit of trial and error. Think of them as puzzles.